Hi friends, in this session we will talk about construction of interest rate term structure using the bootstrapping methodology. For this we will use treasury bonds. This section is very important for FRM Part 1 as well as for the CFA exams. So make sure you understand this concept properly so you can score the question in the exam, right? So here we will see illustration, and using that illustration I will try to deliver the concept. You have to ensure you are able to calculate or calculate the term structure, right? Some students feel this concept as very difficult, but I think this concept is very easy. The problem is in the multiple steps involved in the calculation. So students feel difficulty because of the calculation steps, right? So number of steps are required to calculate the this term structure, right? So first is the illustration. In this illustration, the information which is provided is the time to maturity. So here we are provided with the 4 bonds. So say just call this as a bond A, B, C, and D. And bond has a different maturity. So first bond is maturing in the 6 months, then the 12 months, 18 months, and then 24 months, like this. With this, we are provided with the bond price in dollars, which is 100.9402, 101.9442, and 100.0562, and so on. With this, we are also provided with the coupons, and these coupons are the semi-annual coupons. Semi-annual coupon is very simple. Like for 5%, it is 2.5% in 6 months, and then 2.5% in 6 months. If you go for the 8% coupon bearing bond, in that case, it is say 4% in 6 months, 4% in 6 months, and so on for the next 24 months, like this. And again, we have FP. If you're not provided with the FP, you have to assume it is 100. Okay, because this bond price is kind of an indicative of what is the face value of the bond. Now, what's happening here? What is the purpose of using this information, and how do we construct the term structure? Term structure is very simple. It is the spot rate applicable for the multiple years. Okay, so using this information, we will construct the spot term structure, and in this we will calculate or find out the spot rate applicable for 6 months, 12 months, 18 months, and 24 months. The meaning of spot rate for 6 months, 12 months, and so on is simple. Understand this. Spot rate for 6 months means if you invest your funds for 6 months, that rate will be applicable for your investment. If you invest funds for 18 months, then that rate will be applicable for your investment. So let's assume, just say 2% for 6 months and just take 4% for 18 months. That is, if you invest your funds for 18 months, you will get a return at the rate of 4%. Okay. Now, very important point, which is used by GAAP as a trick in the exam. Meaning of spot rate 6 months, spot rate for 6 months, and it is equal to say 2%. This means this spot rate is that is in the annual terms, for year, annual. This is annual rate. Always remember, all the rates, if you go for 24 months rate, all the rates are the annually quoted rate. This rate is quoted in the annual terms, but is applicable for 6 months investment period. Meaning, if you invest for the 6 months, say 100, then you will get 1% return on this. How 1%? Because its rate 2% is quoted for an complete annum, right? So for full year, and it is applicable. So we are investing for the 6 months. So the rate will be applicable is the 1%. So you will get effectively 1% only, like this. Okay. And if you take say 24 months rate as 5%, then it is annually 5%, per annum 5%. Okay, and then for 24 months, obviously we will calculate for the 24 months again. So for 6 months as well as for the 12 months, it is always applicable for annum. It is quoted in terms of annum. There is no scenario GAAP will provide you the information which is quoted in say 6 months only. It is not possible. You will always get it in the annual rate, right? Now let's see how to start with the calculation. So before we begin the calculation, first let's talk about the D as an illustration, and then we will move further. So if you just look at this D, the bond D, and if you plot it on the timeline, then 6 months, 12 months, 24, 18 months, and then 24 months. and this is time t0 today, and we are calculating the bond price, or we have the bond price which is applicable for today. What is the price here? So it is 102.0194. Okay, and bond provides, or bond bears a coupon of 8% semi-annual, meaning you will get 4 in 6 months, 4 in 6 months, 4 in 6 months, and 4 plus your face value, maturity value at 24 months. Okay, so the cash flow or cash inflow works like 4, 4, 4, and 4 plus 100. Now, how do we arrive at this particular price? So we simply discount it, this, and then this. So we will discount all these 4 cash flows and then sum it up, and you will get the price of the bond. This is as simple as that. For discounting of the first 6 months cash inflow, we will use spot rate, or we use spot rate. The information is absorbed in the bond price. We use spot rate, which is applicable for 6 months, and then same is applicable for, say, when you are discounting the 12 months cash flow, then spot rate which is applicable here is for the 12 months, and then spot rate of 18 months, and then spot rate of 24 months, like this. Okay, this is spot rates information. So we are discounting it at time t0 like this. Fine. Now, how this particular thing works, okay, how bootstrapping works. So in bootstrapping, our goal is to identify or find out the spot rate which is applicable for 6 months, 12 months, 18 months, and 24 months, because this information is already absorbed in the price of the bond. Okay, now see, we have to start with the bond which is of, say, 6 months or the shortest duration, for which we want to calculate the bond price. Now here I provided the complete timeline here. Now you can see time t0, 6 months, 12 months, 18 months, and 24 months. This is a timeline. And at 6 months, and these are the different bonds, A, B, C, and D. So 4 bonds. So for first bond, which is maturing in the 6 months, so what will happen here? It is simple. In 6 months time period, you will get coupon plus face value. So that's why coupon plus face value. C1 indicates the coupon of first bond. Okay. So here we have a bond A, then we have bond B, C, and D. Now see here. Using the first bond, which provides the information of price of the bond, coupon, and face value. Okay. What is the coupon here? Coupon is 4% semi-annual, 4% semi-annual, and FV is 100. So you have all the information. Okay, that is the price of the bond, C1 and FV. And this D.5 is the discount rate, or the discount factor, DF, discount factor, which was used to arrive at the price of this bond. So in the first step, we will calculate the discount factor. Okay, using this information. So here we have very basic information, that is 4%. Let me check. 4% coupon, it's 5%. Yeah, it's 5%. 5% coupon rate, not 4%. So 2.5 in 6 months plus 100, and you have D 0.5. Okay, so let's write down this information. 4902 is equal to 102.5 multiplied by D 0.5. So you have to simply divide 100 and 100.4902 by 102.5. If you do this, you will get 100.49902 divided by 102.5. And the answer is 980,392. So this is equal to D 0.5 is equal to, I'll just give you this step, 0.4902 divided by 102.5, and the answer is 0.98039. So this is the discount rate, that is D.5. D.5. Now, the good thing about the bootstrapping structure is if you place all these bonds in one matrix, so you will get, here you have prices. This is for 6 months, this is for 1 year, 1.5 year, and 2 years. Because this section is applicable, or this structure is applicable for 6 months. So this is the cash flow applicable for 6 months. So we will use obviously same discount rate or discount factor, right? Because this must have been discounted at the 6 months spot rate. So as soon as you get D.5, you got all this information. So all these terms are now solved. Okay. Next, we will talk about the second bond. For now, let's reserve your discount factor, and I will solve only up to 2 bonds, and then you can carry forward with the remaining bonds. So here we have information. Information is available. Just a second. It is, discount rate is 0.980,392, and coupon is 7%, that is 3.5%, right? Or 3.5 in simple terms. Here you have 3.5 plus 100, which is equal to 103.5, and then you have D1. So in this second bond, our goal is to get or use the discount factor calculated in the previous bond, and then we will use it to calculate or find out the discount factor applicable for 1 year. Okay. Now let's multiply this 3.5 multiplied by 0.980392, and you will get the answer here is 3.4313, and transfer it here. So it will get reduced because currently it is in the addition term, that is minus 101.9442. So answer after adjusting for this, that is the discounted coupon, it is 98.5128. Okay, 98.5128, and then this is plus 103.5. So if you solve this, you will get 103.5 multiplied by D1 is equal to 98.512. Okay, so this is now solved term. Again, if you solve this, you will get D1. So to solve this or D1, you have to simply use D1 is equal to 98.512 divided by 103.5. 103.5, and answer is 95.1814. Correct. D1 98.98, sorry, 0.951814. Okay, so you got the discount rate or discount factor of this. So obviously automatically you will get, there is correction, this. Okay, so all 3 discount factors, and here you already have these discount factors or this discount factor, right? Now if you go for this third bond, so you already have this term solved, adjust it with this term, and then automatically you will be left out with this 1x as in the only variable available which you want to calculate, that is a D1.5, and then you will calculate D1.5. So you will have D1.5, and in for bond 4 you will have all the information, and then you will have the discount factor D2, that is a discount factor applicable for the 24 months. Okay, so you can calculate this discount factor now. So the steps are simple. I will give you the revision of these steps. First, you have simple information 100, and this was 102.5, and this term was missing here. So you will calculate D.5 using the first bond. Now you have D.5 for the second bond's calculation. You have D.5, you have this information, D1 is left. So we will use the remaining information and calculate the D1. In the next bond, you have D1, D.5, which is calculated from here and here. And now you're left with the D1.5, which you can calculate again using the same methodology, that is 100 minus term A and B. And then you will have this C3 plus FB is equal to this term, that is after adjusting for A and B. And in similar fashion, you will calculate, or you can calculate, the remaining discount rates, right? Okay. I will directly use the discount rates here. Now let's see the discount rates. So discount rate. So here we have 0.980392, 0.951814, 0.915142, and then 0.871442, 71442. Okay. Let's talk about the first discount rate. So first discount rate was applicable for this, and the value is 0.980392. If you convert this rate into, or discount factor into rate, so we have to simply put like 1 by 0.980392. Please be careful here. So here we have some trick point, 980392, and then 1 by x. So answer is 1.02000, and so on. You have to use like -1, which will give you 0.02. Now remember, this is the effective rate of 6 months which was applied for discounting. This is for 6 months. Okay, and we have to quote spot rate in annual terms. This is applicable 0.02, that is 2% is applicable, but you have to quote it in the annual terms. So you have to multiply it by 2, which will give you 4%, like this. Okay, so you got the first spot rate like this. Now we will use the discount or discount factor of, say, second year or second period, 12 months. 12 months. This discount factor is applicable like this. So we used discounting for this period and using this discount factor, which is 0.951814. Again, we will apply the same methodology here. So 1 divided by 0.951814, and then 0.951814, 1 by x, and then you will get 1.050625. How do we arrive at the second discount rate? So for this, just understand the formula, which is 1 plus r divided by 2 to the power 2, because it is for the 12 months and 6 months and 6 months, right? This 2 is divided, like we are dividing it by 2 because it is for the 6 months. And the result was this, that is this. Okay, so 0.951814, like this. Now what we did here, we used 1 by x. So when you use 1 by x, you are getting this particular part. This, okay, that is the 1.050625. Once you get this, you have to take the under root of this because you have square here, so that square will be eliminated. When you take the under root, the answer is, after taking under root, the answer is 1.02500 and so on. This plus 1, you will reduce 1. You have 0.025 and so on. And then you have this divided by 2. So you have to multiply it by 2. Multiply it by 2. So you will get 5%. So this is how you get the 5%. Okay. Again, this is applicable only if you are provided with the, like GARP asks you to calculate the semi-annual rate. Okay, semi-annual rate. If GARP asks you to calculate the spot rate in the continuously compounded format, then the process will change. I will tell you the process, but it will change. Okay. Now the third part, just a second. A third discount factor, this one. So simply 1 by 0.915142, 0.915142, 1 by x. This gives us 1.092772659, and then you have to take cube root, that is we can use one shortcut here. Okay, now see, when you get this particular part, simply press ln. When you press ln, you got the discount rate which was applicable for the whole period, that is for all 3 periods, 18 months. Okay, and if you press ln at this point, this is 0.08867, just again 67603, like this. Okay, now divided by 1.5, and then you have to press, if you divide it by 1.5 because it is for the that is 3 periods and you want it for the 1 period only. Okay, so if you divide it by 1.5, you will get the rate which is applicable for this 18 months. Okay, so 18 months, sorry, for annum, this will give you the annual rate. Okay. Now when you get this, now you have to press second and exponential, and when you solve this, you will get 6% rate. Okay, and in similar fashion you can proceed with the other calculation, which is again easy to do, easy to perform. It is if GARP asks you to calculate rate in the continuously compounded format, then what you are supposed to do is just take or just assume this particular part. So this particular portion will work in the same manner, that is a 1 divided by 0.915142. I hope I'm writing it correctly. 91, no, sorry, it is, yeah, 915142, right? Press equal to, then press ln. You will get this term. Press ln. As soon as you press ln, you will get rate value, and you have to divide it by 1.5, like this. And the rate which you will get is 0.059117, like this. Okay. Now, better approach if you want to calculate the term. Okay, so what we did here is we divided by 1.5 directly. If you want to make the precise calculation, the accurate calculation, ideally you should do this, that is 1.0927269. This was the result. Okay, 1.092 1.0927269, then press ln, then divided by 3 instead of 1.5, divided by 3. It will give you the semi-annual structure. Then press second exponential, then minus 1, and then multiplied by 2. And then you will get 5.999 and so on. That is 6%. So this will give you accurate results. Right now my calculator is not working. So if you want the calculator explanation, just drop the comment. I will provide the calculator explanation as well. I will provide a separate video on the calculator, how to convert this particular factor into the effective rate, which is the semi-annual effective rate. Okay. So this is very easy calculation. You have to just ensure the rate which you are calculating is the correct rate. All the problem here is in the rate calculation. Okay. So this particular step is not that difficult. This portion is not that difficult. You can calculate it. Don't make mistakes here. Please make sure you are calculating whatever is the GAP asked for. That is, if the GAP asks for the semi-annual rate, then I have to calculate the semi-annual rate. If GAP asks you to calculate continuously compounded rate, then you have to quote it in that particular term. The chances are you will be like, you need to calculate these two terms or these two spot rates. Okay. And the series of this spot rate becomes a term structure. This is upward sloping term structure, like this, right? So this is about the bootstrapping and using the bootstrapping of the interest rate term structure using the treasury bonds. So if you have any queries, you can drop in the description and I will help you in those queries. Okay, so that's all about bootstrapping term structure. So see you in the next video. Thank you very much.